Okay, good morning. This happens to be our third, uh, let me see, video. That's for the online. Please, whatever that I deal with you on this kind of online thing, please take note of things and let me have questions on your page. I don't know whether I've opened the page, but then when I open the page for you, giving you the permission to post your views, please. I want everything to be relevant to what I've taught. Don't be discussing irrelevant stuff there. So, for today's lecture, I'll be taking you through some processes of design. Then after that, we will try to talk of some simulation tools for what I'm going to use to be teaching you. So, first of all, let's talk of design process. So let me share my slide. Okay, so that is it. In the tech world, we have this design process. That is, if I want to come out with a solution for a particular problem, what are some of the things that I follow? Or in the design world, what goes on to come out with an innovation? You see, you'll be there, somebody like Elon Musk will be able to penetrate the market. You'll be there, somebody like Bill Gates will be able to penetrate the market. How did the person do that? There is a lady I used to, I always use as a role model for my students that I teach in, uh, let me say, IT and computer science. The lady is madly intelligent. She's called Lady Ada. That is the nickname, but then I think the right name is there. She developed something called Ada Foods. It's a particular web-based system that she has used to propagate the use of, or to help the use of what? Internet of Things. The lady is very powerful. I should have brought a picture here, but then it's rather unfortunate. You can also go and search for her, Lady Ada. Fine. So how are these people able to penetrate the market? And we are going to look at that because these days we are not training you to come out as brilliant students and start going around writing letters to be searching for a job. Our aim of teaching now has changed, or our purpose, or let me say our objective has changed now. So whatever that I teach you, please, at the end of the day, your dream should not be kept in the notes or at the laboratory. I want you to go out, use those ideas, and also influence the market. So let's continue. The design process, we have problem identification. You see, the difference between you and the one that is at the roadside, also learning the same either electrical, computer, or IT. The difference between you and those people is that you have the ability to identify problem because we've been able to do a lot of problem formulations in our courses. That's why you do thought courses before you come and do practicals. So within the thought courses, the way the problems are always formulated, it gives you the strength to be able to look at the world or the society and come out with an innovation. An innovation in such a way that you'll be able to see something as a problem, not problems that we discuss about. Just recently, I met some electrical students and I told them that what I hate is complaints. Complaints, excuse. But let me tell you, complain and excuse, they are all senior brothers to failure. And failure too is a senior brother to poverty. So take this term from me now. Whenever there is a disaster, please, as a tech student, see it as an opportunity. Any disaster that strikes, whether it is in your home, in your society, in the university that you're schooling, whatever that comes, and you see one, two, three people complaining, it becomes an opportunity. Let me tell you, when we come for weekend lectures, that's PhD lectures, we normally come in the weekend. See, getting water to buy is always a problem on a UNE campus. Trying to get food to buy like that, those kind of things are stressful. At times you have to walk down to Fairplay over there to take some food. But then, you see, we've been complaining. PhD students are complaining, master students are complaining. Sometimes BSc students who are also doing weekend, they complain about these things. But you see, nobody is willing to say that, okay, if I have seen it this way, that is an opportunity. It's just an example that I'm citing. Why don't I sit down and say that, okay, if I know that food is always a problem, though I'm a student, I'm a part of the students, this is what I'm going to do. Let me start collecting maybe some amount, 30 cities, 30 cities, 30 cities from my colleagues. Then I will rather contract somebody somewhere for the person to prepare the food with the water and all those kind of snacks that will be needed. Then the person convey it down. After doing that, a lot of problems comes, but then you try to solve it. Then at the end of the day, you get a business. So this is the way you should start thinking. As I said, when you see a disaster, see it as an opportunity. Simple. Let's go to the next point. So problem identification is that you'll be able to know whether there's a problem. And it's a problem that we don't want to complain. It's rather a problem that will give you opportunity. Number two, if you see a problem, if you're able to identify the problem, how best were you able to link it with the course that you are doing? So let me tell you, you are in a village. At least every weekend, there will be a funeral. There will be, let me see, a wedding. Then, within that village, there's nothing like printing press. Meanwhile, you have a laptop. You are using it to play game in the room. Now, people take motorbikes, go to the next town, design these kind of wedding cards, brochure, funeral invitation cards, and all those kind of things, do photocopy and other things. Back to the village at a high cost. So you as an IT student, what are you doing about that problem? Because I know you yourself, if you want to also want to even print your assignment, you have to also pass through the same hustle. As an IT student, how do you link such a problem to the course that you're doing? That makes you a strong tech student. See, the problems are there, plenty. But how am I able to link it with the course that I'm doing? So in here, we call something problem formulation. So problem formulation is where I'm able to come out with the objective function. Objective function in such a way that clearly define what you want to do. But after you've defined what you want to do, be ready to meet constraints. Be ready to meet constraints. And the constraints are the problems that you meet on the way when you start to solve a particular problem. I don't know whether you are getting me. So in this world, the world is not as cheap as we see it. Until you start to do some work, you will never know. Let me give you an example, a simple example. You can sit back on the bench and be discussing with a colleague that, oh, this student, I see there's no kinky on this campus. People would have patronized in this kinky. Okay, then we take a pen. Then I said, okay, I buy maybe maize or whatever. The cost is maybe after doing everything, maybe the cost will be maybe 20 CD, 200 CDs. When I finish the kinky, I bring it down. Then maybe when I sell it, maybe I've been able to mold about 30 balls. When I finish everything, I'll be having about 300 CDs. Then when I deduct the 200, hey, then the 100 is a profit. Assuming every day you are getting 100 CDs profit, it's big money. Then you jump into such a business. Please, immediately you jump into the business, certain things will start showing up, of which you never plan about. One, income tax will meet you on the way and they want to take tax. Two, remember you have to take dropping. You can even be coming, the car can get spoiled. Or you can even be conveying the food. Some of them can even be poured. They can even fall on the ground. A lot of issues. So until you start, you will never know these kind of constraints that I'm talking about. But then after you started and these constraints are coming and you start solving them, that makes you a strong tech student. As simple as that. That makes you a strong tech student. So that is why you have to formulate your problem. That one, you look for your objective function, then you think of how to what get your constraints. Right. The next one that we talk about is solution design. What do I mean by solution design? Well, when we talk of solution design, I think my PowerPoint, okay, was locked, so forgive me. So we are done with the problem formulation. Then we go to solution design. Solution design as a tech student is always done on your laptop, in your room, or in the laboratory. So if it is electrical, computer engineering, computer science, you do it at the laboratory. Well, IT too, we do it at the laboratories. But most of the times we develop our softwares on the laptop. Now you have a long time. You have enough time to what? To always be interacting with your projects. So this is what happens. I'll be able to identify the problem, formulate it, and be able to know my objective function. This is what I need. Now the constraints are coming. I try to know how the constraints are, or I'm able to list them down. Then I design the solution for it. The problem that I've been able to find. This is something that I want to just show you. Let's say I have a bulb in my room with a roommate. That roommate normally leave that bulb on without switching it off. Well, as a tech student, I shouldn't see that one as a problem. I should be able to what? To formulate that problem or be able to link it to the course that I'm doing. So I per se am an IoT student. I've done IoT for long. So what I'll just do is that let me design a circuit in that room, connect the circuit to the bulb, then I link the whole circuit to the internet. So whenever I am in the lecture hall, I should be able to monitor the bulb state in my phone. So if the bulb is on, I'll be able to know. If the bulb is off, I'll be able to know. So there I can even switch it either on or I can switch it off. That's the design that I've done. So let me say that's the design that I want to do. Sorry, this is not a picture that I captured from my lab. I just took it from the internet, but I'm just showing you. But there are more projects that I have like this. Now, so if that is what I've been able to come out with, then it means I've solved the problem. But somebody will say that no, we've not seen what you have done. This is the stage that I've seen that most of students' ideas has been kept at the lab. I want to make this thing clear to you. Anytime you design a project, you design a software, or you design a circuit, you design a mechanical system, mechatronic system, IoT system, you bring it to the lecturer praises you, they give you A plus on your transcript or on your certificate. Then finally, we take this project and keep it at the lab. You see, the farthest that it can be kept there is about 1 year. Everything we ship it away. Immediately you do that, your dream has been kept forever. And I don't think you will come back to it again. But let me tell you, in this tech world, we don't design and keep it in the lab. We design and take it and penetrate the markets. So after you've been able to do something of this nature, the next thing for you to do should be the implementation. And that is what a lot of people are running for. You see, after designing like this, it works very well. But you've not implemented it in the hostel yet. Now go and install it at the hostel. There that you see that the world is also ready to meet you with challenges. Immediately you want to mount it, the school uh, maintenance office will come in. Master, you cannot touch the school bulbs, the hostel bulbs, and other things without contacting us. You want to mount it, maybe you've never dealt with high voltage before. So at the end of the day, you'll be having a lot of constraints, a lot of problems when you want to what implement. So let's see something. There is something that I want to show you. Example, you see, this is a phone. This is a mobile phone, a simple mobile phone that you can design. We have our mouthpiece, earpiece. Then we have our antenna. This is a GSM model with a what? A chip inside. Then we have a keypad, we have a screen. Then we have the controller. This is the simple mobile phone that you can design. Yes, there's a course that I'm not teaching this semester. I would have let the students design one for us to do demonstration, but I don't teach embedded system this semester. I would have let you do that. I would have let the students do that. So this is a phone. So after I've been able to design the phone, how do I implement? That's where the problem comes from. Maybe this thing, if I put it together, it will be very big. What will I compare it to? It will be bigger than maybe three times of a mathematical set, the size of math sets. It will be more than it for about three times. So with this, if you take it to the market, I know people will be laughing at you. Definitely, people will be laughing at you. And immediately you laugh at somebody's project as the person is coming out with it in the market. Immediately you do that, you shut the person's dream forever, as I've already indicated. There are certain things that put us down, but Ghanaians or Africa as a whole, we don't pay attention to those things. So a lot of projects are in the lab now that are not out yet, all because we lack the idea or we lack the strength or the power to push it into the market. So that is the implementation stage. A lot of things has been blocking us. Some people say that mine is a new one, and I know people have already captured the market. How do I also? No, there's something we call SWOT analysis. SWORT. It is SWOT rather. Please go and read about SWOT analysis. The business people will tell you if you want to penetrate the market, there are a lot of things that you should take into consideration. You yourself have your strength, that's the SWOT. You have the strength, you have the weakness, then I think you have opportunities, then you have there's another thing we call it the T aspect. So maybe as time goes on, when I remember, I'll mention it to you. So you see, take care of all those kind of four statements. They'll be able to penetrate the market with your design that you've come out with. So that is it. So immediately you go to the market and you want to implement your thing. Now, assuming you design, let me start with the electrical and the computer engineering side. Assuming you design a solar panel, the lab is working perfectly. Power consumption becomes reduced. You are getting a lot of efficiencies, and that one is still in the lab, and you now want to take it out. You want to scale up. Then somebody is interested in your project. You want to now install for the person. You see, when you were designing at the lab, you never thought of climbing a ladder. But today, look at those guys on the roofing sheets. It means a lot of challenges over there. If you joke, you can just fall down and die. So, as I told you, penetrating the market is not a simple job. That is why you came to school. So, we want to equip you with all these strengths so that whatever that you design, don't let it be in the lab, take it to the market. Now we go to the right-hand side, the IT guys. What I want to tell you is that sometimes you can design a software which is very perfect, but it is only on your what? Your laptop. It's only your laptop that you're using to run the software. Now, if you want to now take it to the company, maybe it's not only your laptop that will run that software. We want it to be able to run by about 100 computers, 200 computers, 300 computers at the same time. Then you start facing the challenges about scalability. Memory footprint will give you issues. computational power will give you issues. Sometimes you can even be running with CPU machines and the machines will be giving you problem unless you go in for GPU machines. See, how do you deal with the customers if CPU is not working with your project unless you get GPU or TPU? You see, all these things are issues that you should be aware of. That is why I hate projects that are designed and being kept at the lab. So all those 100%, 90% of work that you were doing, please. And I heard something and now it was miserable to me. A student came to me and he was saying that there is something he has been designing. But I said, oh, so he should let me have a look at it. Then he told me that no, he normally does it and he dismantles it back because he just do it as a fun. Please. Doing something as a fun in the tech industry is not allowed. We don't do anything as a fun. Do it, package it well, penetrate the market. If you can't send it to the market, please come and see me because this is our aim now. Because I don't want you to complete school and start writing letters for jobs. Try and let us market your ideas. Simple. So, the next thing is what we call review and maintenance. There's another critical thing too I told my guys recently. Please, when you finish any project and you go and implement it on the person's system or your customer, please leave your contact. When they call you, please pick. Give them a timeline. Every 1 week, I will come and do maintenance or I'll come and check. Maybe maintenance, you do it for free. You see, you are saying that people are already in the market because some electrical students were telling me that we have people in the market who are always wiring people's house and whatever. So how do I also get to the market and get customers? Those people are already there. They've made a name. They have a brand. Then I told them that they should also design their own branding. How do you get your own branding? One, if I wire your house, when I finish wiring your house, the first thing I'll give to you is the manual of the electrical circuit that I did in the house. And this thing is not done by any electrician in town. They just come and do the work and they go away. No manual. But show this customer that you have been to school and you know what you're doing. You give them the manual, then you tell them that after every 3 months, you will come and do maintenance. If I were you, when I even go to the house and there is nothing to even maintain or to do as a maintenance, I'll just remove the bulb, clean it, put it back. Look at the sockets, make sure all your circuit breakers are on. So that is it. Ask them questions, please. Are you having much consumption in this house? If there's much consumption, you check your earthing system. I'm speaking with electrical language, forgive me, because my target is not for only electrical, but IT, you understand me. At the end of the day, you design a software for somebody, you install it for the company, they are calling you and you are not picking. That is the greatest thing that will shut you down forever. And you will never come back to the market again. Because immediately you start doing that, you are blocking your way to be known by the community. But if I were you, please, when you design the software, go and implement it. I told you that don't design a software and leave it on your laptop. No, go and put it on somebody's system. Now try and monitor, try and do maintenance, try and review, ask them questions. So that is it for all these design process. And I know as time goes on, I'll be mentioning some more. So that is it for now. So our next topic will be simulation, but then yes, we are talking of electrical quantities, but I'll talk of these kind of simulation softwares. We have multisim and the next one is Proteus. So I will start doing some small demonstration for you to see. But then I think the video is a bit large now. So let me just stop it here. Then my next video, I'll try to do the demonstration for you to see. Thank you.